Business modeling is a solid topic in accounting. In auditing and systems courses, you learn different ways of documenting business processes. There's data flow diagrams, BPMN, and other types of flowcharts. But data models are a visual representation of how information is stored and related. They function as a blueprint to know how to design an information system, but they also serve as a common language of communication across different stakeholders. They are a clear and concise way to discuss information structure. So, we're going to start the course by reviewing relational data modeling, primarily because relational databases are still the most common way that companies store and manage their structured data. So, as a precondition to analyzing relational data, you need to know how to first query a database. We're going to start with the fundamental concepts. Hopefully, this comes to you as a review. But even if this is your first exposure, or even if it's just been a while, I'm going to start from the beginning. Relational data models consist of three main building blocks: classes, attributes, and associations. A class is some general category, a discrete collection of things whose data we want to store. Then the attributes are the specific things or dimensions about a class that we're going to be tracking. Lastly, we've got associations. Different classes may be directly related to each other, and we explicitly designate those relationships with associations. Now, let's look at this in terms of a class diagram. These are commonly used to model relational data. Classes are represented with rectangles. Depending on the level of detail in a diagram, this might just be a box with a single title of the class in the middle of it. Or you might see the various attributes of a class listed below. For example, companies are certainly going to store data relating to their employees. This would be the more general class, and the various attributes of employees, whose specific values we would track, might include an ID number, their name, the department they work for, in addition to many other employee-specific information. Let's keep working with the employees class and demonstrate how these things manifest in an actual database. Now, I want you to realize a data model is conceptual. A model visually shows the theoretical information structure. But once you're working with an actual database, we're going to use different terms to talk about essentially the same thing. When working with a database, a class is referred to as a table. So this would be the employees table that tracks the data that we specified would be collected and stored per the employees class in our data model. Each of the columns in the table are referred to as fields. These are the attributes in the employees class. And each row of a table should reflect a unique observation. In the database, these rows are called records. It's good to know both sets of terms and to remember which is used for a conceptual data model and which ones refer to elements of an actual database. Let's move on to that third building block, associations. Data is stored in standalone tables for the sake of efficiency, but the data contained in one table is often directly related to data contained in another. And when data is stored like this in Excel, you would typically think of using lookup functions to merge data across multiple worksheets. But relational databases improve on such an approach by explicitly specifying associations or relationships between two classes. Not all classes or tables are going to have these direct relationships, but for those that do, we formally specify these in a data model by connecting them with lines. For instance, we might have data about all our company's employees stored in a table, and in a separate table, data about our company's various locations. If there is a direct link between data across these two tables, we would mark an association line and set up the relationship in the database. It's important to note that associations work in two directions, and you ought to be able to express these going from one table to the other and vice versa. Another term to describe this is the cardinalities. These will depend on how the company does business, how it runs its operations. For example, a likely situation for many companies is that any given employee works at one and only one location at a time. Expressing this from the locations class, A given location may have, at a minimum, one employee, but very likely associates with many employees. Thus, going from left to right here, we would have a many to one relationship, going from employees to locations. When indicating these relationships, you'll sometimes see it expressed with ones and M's, or in other cases, ones and stars. When I say the word many, this just means multiple. It doesn't necessarily mean some large number, just the fact that a single instance from one table could potentially relate to more than one instance of the other. In a relational database, every single table is going to have a primary key. A primary key is an attribute that uniquely identifies each record or row in a table. Every record must have a value for a primary key, and they must be unique. No duplicates are allowed. Sometimes, primary keys can be natural, derived from existing real-world data, like social security numbers, phone numbers, or VINs. But often, the best primary keys are assigned sequential numbers because they ensure uniqueness without relying on external data. A foreign key is a field in one table that serves as the primary key in another table. This is what links them together, establishing relationships between tables. In a one-to-many relationship, the table on the many side is the one that hosts the foreign key. Now, let me be clear. It's perfectly okay for values within a foreign key to repeat over time. What is important is that for any given value that a foreign key takes on, it should trace back to only one single row of the table where that same field functions as a primary key. For instance, let's assume we've got data on customers and orders. The association between these tables is likely going to reflect a one-to-many relationship. This would mean that a given order is going to correspond with only one customer at a time, but a given customer, hopefully, can be associated with many orders. It's not like we sell to a customer once and we're done selling to them ever again. No, it's more likely that a customer could be associated with many orders. Since the orders class is the many side of this association, the primary key of the customers table, customer ID, would be included in the orders table as a foreign key. I want to try this again for some practice. A logistics company manages customer orders for various retailers. A given shipment likely relates to several orders, but each order can be linked back to one single shipment. You might consider pausing the video now and see if you can express the cardinality of this relationship and then determine which table is going to host a foreign key. So what is the relationship here? Going from orders to shipments, this is also going to be a many-to-one relationship. Many orders can associate with a single shipment. And since the orders class is the many side of the relationship, the orders table will host shipment ID as a foreign key. Let's move on now to actually apply these concepts in an online database management system.